we can, okay, we can ask our question, have an open discussion. So I will leave the space to Nicolas.
Okay. So we're going to have time for a question at the end of the session or right after each talk?
At the end of the session, if you can join us for the open discussion.
Okay,
If you can't, we can take a couple of questions after the talk.
Okay.
Okay.
Okay, so I'll try to share my screen now.
Okay.
Here we go. Can you see it? Okay.
Yes. Yeah.
I'm gonna go full screen now. And there you go. Everything's good on my side.
Yeah, we can see it. Thank you.
All right, go. Thank you. Good morning, everyone. And thank you, Erika, for giving me the opportunity to introduce OpenPlanetary to this network. I think it's going to be very useful for you. And I entitled that talk, Introduction to OpenPlanetary as a Resource for Early Career Researchers. My name is Nicolas Mano. I'm a planetary data engineer and software developer with involvement in past and present planetary mission. And you see here the list of all the people who are currently leading the OpenPlanetary organization. So in brief, what OpenPlanetary is as a non-profit organization, which was established in February 2018. And the mission is to promote and facilitate the open practice of planetary science and data analysis for professionals and amateurs. And so we do so by organizing events, conducting collaborative projects, and creating scientific, technical, educational resources, tools, and data accessible to everyone. So we're currently about above 320 members, made of planetary research and education professionals, as well as space enthusiasts and scientists, citizen scientists. We are a community-driven organization, that is intended to serve as an umbrella for all communities of planetary data and tool users, producers, providers across all scientific disciplines, space missions, institutions, and working groups. So it's not intended to be another community, it's intended to be an umbrella for every community with a focused topic on planetary data and tools that you use for your research. We use as our collaborative framework or platform, we mainly use Slack and GitHub. We have a GitHub organization. I'm going to give you a brief history of OpenPlanetary, how it started and where we are now. So it started in 2015 as an initiative from the participants of the Planetary JS workshop at ISAC in Madrid. And so the idea there was to try to stay in touch after and between this type of workshops where we communicate a lot, and when we are away, we could lose that link. So we initially created a Slack instance and a GitHub that we've been building and using for the first 2 years. And we held our first event at the EPSC 2017 in Riga, an event that we call Data Cafe. And you can see on the right side a photo of this first Data Cafe, and the idea of this cafe following an unconference format, meaning that every participant can actually make the agenda and can bring their topics, their issues they want to discuss, a demo or a tutorial or a hack. So this is the first year. It was more of an initiative, and in 2018 we decided to establish OpenPlanetary as a non-profit organization, and the main reason for that was to be able to find some funding mechanism to be able to sustain this initiative over the time. And we had during that year a second Data Cafe we organized at EPSC as well. And about a year later, we had our official launch of OpenPlanetary at the 4th Planetary Data Workshop in Flagstaff, USA. So the official launch means that we officially started to register members. Membership is free for OpenPlanetary, of course. But we also, at the same time, we launched our public forum. And we had a presence at other workshops during that year, including the planetary mapping, the Nature Observatory workshop in Paris. And again, a third data cafe that we organized in joint EPSC DPS in Geneva. That was 2 years ago. So that was going pretty well. We were getting some momentum. And last year, the pandemic happened, and we knew that we were not going to be able to do these face-to-face events anymore at conferences. And so we started to organize and host online events. We started with weekly events that we called OP Lunch or OP Virtual Lunch Talks that we've been doing since March last year and are still running now. During that year, we also had our first OpenPlanetary virtual conference, and at the end of the year, we had our first OpenPlanetary General Assembly, the General Assembly of the association, where we elected the new board of directors. And here we are now. So I'm gonna stress the aspects that might be of most interest to you. So starting with the OpenPlanetary forum, which is something that you don't need to be a member of OpenPlanetary to use, because it's a public forum. And the idea is to provide this forum for all research professionals and amateurs across, again, all scientific disciplines and community. And the idea is to, as a forum, to find out, share, and discuss data, tools, and resources. The way we use the forum at the moment is because we have Slack for members, and we have lots of real-time discussion going on. And so what we aim to do is to try to surface the gems or the best discussions or information that we have during, in this Slack real-time discussion environment, and bring them to this public forum so that it has a permanent web presence and it's searchable on the web. So essentially, people that would end up on this forum would be like anybody. You know, when you do a search on Google and you end up on the forum, you find your answer. But the other way of using it is by being proactive. If you want to use it as a platform for posting resources to others, maybe anything that can be a resource for others. This is the idea, and you can sign up with your Google account, your GitHub account, or email. And you need to sign up if you want to be able to post, or just to receive, for example, forum activity summary emails. So you can see on the left-hand side some of the categories and subcategories that exist at the moment: data access, discovery, discussions on planetary data sets, tools and web services, programming, events. So I encourage you to go and explore the forum and sign up. Feel free to do so. Open virtual lunches, as I mentioned, it started last year, and so they are every Tuesday at 2 p.m. Eastern time, which means that it's 8 p.m. Central European summertime here. So it's not very much a lunch hour, but it's because the initiative started from Chase, who's one of the co-founders of the association. And but anyways, the idea is really to present in a casual, friendly environment, discuss technical topics of interest to planetary scientists in general. So if you want to participate, you need to subscribe to receive weekly invitations. Or sometimes it happens that it doesn't. We skip one because we don't have a speaker or we have other conflicting meetings, but essentially it's every week. If you miss the talk, or if you want to know what we talk about in this type of events, I really encourage you to go to our YouTube channel. We've been accumulating a lot of very high quality videos. I mean, high quality content, not the resolution of the video or the frame rate or whatever. It's about the diversity and the quality of the content of the speakers, of the topic. I think we are reaching about 50 talks at the moment. So, and you also can propose a talk. Again, it's a friendly audience. It's good for practicing. So I think it's kind of relevant for early career researcher. And for that, just send us an email at team@openplanetary.org, or myself, Nicolas, at openplanetary.org. I wanted to broaden the content of this YouTube channel, but maybe I'll keep that for later, just to make sure I have enough time to cover everything. But please feel free to go there, and I'm sure you will find something that interests you. Just a few words about this virtual conference that we organized last year. It was in June, and it consisted of lecture-length talks from invited speakers. We had networking opportunities and workshops, tutorials, and even a hackathon. Same thing here. Most of the talks have been recorded, and they are available on our YouTube channel. So you can go ahead and head to the OP Virtual Conference playlist. If you want to know more about the program and some more information, especially for each talk, also including the launch talk, we post a post or a topic, as we call it, in discourse form. We post one entry for each talk, which gives you, anybody, the possibility of engaging with the author of the talk, or anybody from the community. You can go watch the video. You can also then go to the corresponding entry in the forum and ask your questions, your comments, or add further extra information or resources related to the topic. So you will find all these links in the openplay.org/vcon. Community projects, as I said at the beginning, we organize events and we try to run or coordinate some community projects, but it's all based on the initiative of the members and the board of directors of OpenPlanetary. So we currently have two main projects that we are supporting. There is OpenPlanetary Map, which is a project to foster planetary mapping and cartography on the web for all. So the idea is to make it easy and collaborative to create and share location-based knowledge and maps of solar system bodies. You see below two base maps that we created, one for Mars and one for the Moon. If you want to learn more and contribute, you can go to this URL, openplanetary.org/opm. And we have this other emerging community effort to develop a core package for planetary science in Python and foster interoperability between Python planetary science packages. Some sort of umbrella, if you like, as well. And the project is called Planetary Pi. So if you're a Python developer, or if you want to contribute, you already have a package, for example, and wonder how you maybe bring more visibility to that package, then this is the place for you to go and check out. This is my last slide. Just wanted to see or ask the question how we could link the two initiative or effort community between OpenPlanetary and EPEC. I've just realized this morning that you already have a Slack channel. But just to say that the Slack that we have, the Slack instance that we have, runs on a pro plan that we have for free because we are a nonprofit organization. because I've seen several times Slack being used by communities online, but as you know, your Slack content is searchable up to a certain amount of data volume, or I think it's maybe or a time period covered that you can search. Anyway, if you want to let's say bridge the two community one way or another, you're really welcome to join OpenPlanetary. Ask for the creation of an EPEX specific or early career specific channel, along with all the other channels that we have, which means that you can have like your own discussions that relate to maybe EPEX itself, or just wander in the different channels that are on Slack that I'm sure that will be relevant to you. So if not, you can get in touch with us and follow us on Twitter. And that's it for me. If you have any questions right now, I'm happy to take them. And yeah.
Thank you, Nicolas.
Thank you. I also want to confirm that joining their Slack channel is very, very useful. Sometimes I was like, I don't know, in trouble because I didn't know how to do something or I didn't remember. And that Slack channel, it's really a very nice community and they're always ready to help you. So yeah, I suggest you to join them. Now we move to the next speaker. And if you have questions, write them down. You can, make the questions to Nicola after this session.
Yeah, I'll stay around. I stop sharing.
Okay, thank you.
Thank you, everyone.
So the next talk is about Vespa. I'm sure you remember when Nigel introduced us all the sub-realities of your planet, and Vespa was one of them. So today we have Stefan Erard. I hope I pronounced that well. Good morning, Stefan. I can see you're here.
Sì, l'hai pronunciato quasi bene.
He said I pronounced it well in Italian. I'm very glad about this. So without further ado, I will leave you the space, Stefan. You can share your screen, so you don't have to say next, please. Perfect.
Okay, so you should see something. I have no idea what exactly, but
Yeah,
this should be full screen, except that this is not the right screen, probably.
It's a presentator mode.
Okay. Is it better?
Yes, perfect.
Okay.
Thank you.
So I also need to shut down my video because I have a very poor connection, sorry. And then I need to see something. Okay, so I will present briefly Vespa, which is one of the work packages in EuroPlanet 2024. Most of the work was actually developed in the previous program, EuroPlanet 2020. So this is a very mature activity now. And this is about providing access to the data in planetary science, in solar system data in general. And as you see, this is a very large group, which involves a number of participants. There are 19 contributing participants, which are laboratories across Europe. And it also works with a contribution from the community, which means external people which are involved in this activity. So today I'm presenting this in a different way. I try to focus on what is your problem as young scientists, probably trying to identify where data of interest are located for you. But the basic problem is always the same. You are a user, you want to access data, you have data available everywhere on the internet, but you do not necessarily know where the data is located, and you do not necessarily know how to actually identify the data of interest for your project. So I'm trying to give you some hints about this and provide a global picture of the situation. Ideally, as a user, what you would like really is to remain seated on your desktop computer, write one query, like I want data on this particular area on Mars in this spectral range and at this particular local time or season, whatever. And you want to write only one query sent to every possible database. So this is not the reality currently, but this is what we're trying to achieve within Vespa. And not only this, because once you've identified data of interest, you want to be able to actually read the data, at least to see them, display them on your screen, and possibly make some analysis with current standard software tools, communicating with each other, and eventually at some point send your data to a more sophisticated environment such as GIS if you're looking for surface data. Okay, so the first question is basically, what will you find planetary science data? So there are a number of places. Most obvious one for you is probably Space Agency archives, which are the PDS, which is not a global system, but a series of individual nodes which do not really communicate with each other. The PSA, which is the equivalent of the PDS using the same archive format, is something more integrated. And there is actually a very nice interface, as you may know. But you also may want to access data from other space agencies, in particular JAXA and ISRO. The Japanese and Indian space agencies have similar interfaces and similar archives. So you may want to look in these different things and link the fact that they are not connected together. But you also have solar system data available in observatory archives, in particular ESO, which is a very large one, and there are in the US a number of integrated archives for several telescopes, in particular orbital telescopes or data are available in the MAST system, and there are other things, Noir Lab, which is a recent integration of several previous databases, IPAC, CADC, which is a Canadian Astronomy Data Center. All those are essentially astronomical archives, but there is solar system content inside, which is traditionally very difficult to access, because if you're looking on any of those for Mars data, you will simply get no results. So this is one of the problems that Vespa wanted to address. A third data information system is a virtual observatory. So again, this is historically something dedicated to astronomical data handling. And this is a worldwide system which connects astronomy resources together. So not only databases, but also catalogs and even data from publications. For instance, Vizier in Strasbourg is a system which actually store and archives and make available data from published papers. And you can look inside this because there is really a wealth of planetary science data inside this, but this is not completely easy to access. And the virtual observatory has started 5 years ago, a big effort to include solar system data in this system. Vespa is about this, of course, but CADC, the Canadian Astronomical Data Center, and ESA Sky in ESA are dedicated astronomical interfaces with a special mode to access solar system data. Then if you're working on surface science, planetary surfaces, you're probably most used to GIS tools, which are derived from tools for the Earth observation. So the planetary GIS are actually mostly from the US side, I think. The PSA has a project, but it is not yet published. So most of those are actually connecting data from PDS nodes, and those have to be prepared to enter such a tool. So if you're working on a Martian surface with, you will find several Martian data sets in this kind of environments, but not all. And usually they are rather closed environments, which means that you cannot include your own data inside this kind of system. But there are very powerful tools to analyze especially reference data, of course. And then you have other systems related to other disciplines. For plasma and magnetosphere and even heliophysics, there are resources using their own system and standards to access the data. And the same is true also for experimental data, in particular spectroscopy, sample analysis, and even atomic and molecular physics in this case. And some of those are derived from Earth observation system. Then you have a number of resources which are simply isolated on websites, and you have to know them to be able to access them. But some of them are very interesting, of course. So how would you look for these data systems? That's a problem in general. You first have to find the resources. So as long as you're talking to the PDS, okay, you can perform searches on PDS nodes, but you have to realize that currently there is no global search system, at least not at data file level in a PDS. So you have to access nodes individually. You first have to pick up the node of interest for you and look inside their content. There are also external resources external to the PDS, but closely connected in USGS, in JPL, in Goddard. For telescope archives, you may have something integrated at observatory level, for instance, ESO. But also at broader levels, the resources I mentioned previously. The virtual observatory is something different because it intrinsically connects resources which are produced independently from one another. So all these resources are actually declared in a single place, which is called a registry. And you just need to query the registry to identify resources of interest. And usually these resources are the equivalent of individual PDS datasets located on one node of the PDS. So how will you look for data? All those are databases, which means that the data are included and available from there, but they are accompanied by a description, which is very formal and which is a set of metadata. So this metadata provide basic info, such as the target name, the kind of instrument, the kind of measurement, these kind of things. Something which is globally called provenance information, which is not only the provenance in terms of space mission, for instance, or observer, but also the history of the processing of the data. You also have coverages, spatial, temporal, spectral, in some cases also in terms of illumination conditions, and any kind of observational or instrumental parameter which is relevant in this particular case. For this system to work, which is you're presenting a set of metadata, and this is used to identify data of interest for you, it has to be uniform across data services, of course. And that was a major problem in PDS3, as you may know, because if you try to work with historical PDS3 archives, you probably realized very early that the same keyword can be used to introduce different information. So it's very difficult to query a PDS3 archive blindly. You have to adapt your query to the particular data set because of these particularities. Telescopic archives usually rely on the FIT standard, which is associated to a set of keywords providing all this information. So it works. It is much more regular than PDS3 was. But of course, the support for planetary science was very limited. In particular, there was no explicit support for moving targets, no resolved coordinates and system on planetary surfaces, and so on. Well, I haven't mentioned PDS4 just because it is much more robust than PDS3, but so far very little data sets are available in PDS4 format. Okay, the second part is how will you query such an information system once you have identified a place to look. So in PDS, you have search engines available, but only at node level. And some of them are actually very efficient, Opus in particular, but also Pilot, and you probably know those if you had to search for this kind of data. There is currently a global search function in the PDS, but only at dataset level, which is an issue. It will just tell you that if you're looking for data on Mars in this particular time range, you will find them in this and this dataset. And then you have to explore the dataset itself to identify files of interest for a particular configuration or something. So this is a very efficient search system, but limited in scope. Something more efficient is being designed for PDS4, but it won't be available before 3 or 5 years, probably. The PSA on this, from this point of view, is more mature, I would say, because there is a global search interface which is very efficient. So you can search on the global PSA content, including using parameters related to geometry condition, which is something very valuable. Okay, GIS is something a bit similar, but based on completely different access protocol, which are from Earth observation and from the industry for most of them. So you may know these words, WMS, WCS, and those. There are ways to write queries to a database system. But of course, they only address geo-referenced data located on a planetary surface. And besides, they are tied to planet Earth, which may be a practical issue. The VO relies on another set of protocols, which are from a consortium called the International Virtual Observatory Alliance. So historically, again, that was focused on astronomy. And one of the action of VESPA was to enlarge this to address also planetary science data. And something that many people do is to simply try in Google to find data of interest. Like, again, a typical request will be, I'm looking for Mars data in this particular time frame, in the near infrared, and in given illumination conditions. But I doubt very much that Google is able to answer these kind of things. So again, VESPA actions are relying on extending the virtual observatory data handling environment by including information and constraints from planetary science. So what we provided, in short, is first a set of metadata which is able to address most of the situation occurring for planetary science and heliophysics. Support for a dedicated coordinator system, which is something important. We also provide a basic user interface, which is a discovery tool. You have to see it like that. This is a VESPA portal, and this relies on the VO protocols. We also provided a lot of content, more than 50 data services open today, including the PSA itself, which is a huge beast in this ecosystem, and also dedicated infrastructure in spectroscopy for metadata and for magnetospheres. And this is connected with tools provided by the astronomy community from the virtual observatories, with updates to support the planetary science data. And I want to stress that this is available, this system is available not only to access data, but also to distribute your result at the end. And this is rather easy to do. So in practice, it means that a data service in Vespa is simply a table with one row per data element. Data elements are usually files, but there can be something else. This can be a catalog of craters on Mars, for instance. And these data elements are described by a number of columns, which are parameters, which are standardized. And you will find, of course, target name, the time range, a link to the file itself, if this is a file, a number of identifiers, and so on. So this is a huge thing. We have like 40 columns parameters which have to be present, and this allows to access, to send the same queries to various services, and nearly 200 standard parameters which are available to provide more detailed description. And in addition, we're asking people to provide thumbnails to show them in the portal. So the portal is a discovery tool to access these things. So the entry page is a list of the service accessible. There is a web interface here to help you write your queries, which is sent to all these services. So that will provide you with a number of results for your query. And if you click on one of these rows, you will access the previous table, but limited to the result of your query. And from here, you can send selected observations to the tool. So I'm not detailing this because I suspect that I'm already a bit late. But we've provided content in many fields, not only atmosphere, surface, and magnetospheres, but also small bodies, solid spectroscopy in the laboratory, and also exoplanets. Again, I'm not entering this, but this is a global scheme of the architecture. You have data services which may have or not have a web interface. You have the portal, which is the discovery tool to easily send requests. The data services are registered in the IVOR registry, the one used for astronomy. And this is how you will look at them. And from the portal, you can send the selected data to a variety of tools which are extremely powerful and that you want to know even independently from the data access context. And I want to stress that once you're, this is used for discovery, again, the portal, but once you're comfortable with the data set of interest for you, you can do the same work from the command line or from Jupyter notebooks, which allows for mass processing of this data. So some comments to finish. EPN core, the vocabulary of metadata, is not only useful to describe database contents. This is also something you can use for your own personal data tables to describe your results, for instance. And this is very helpful because it provides you with a standard vocabulary, which is optimized for a number of things. So if you're producing tables, even if they are not published, you may want to use EPN core to describe them and to make an easy connection with the tools from the VO. This will be used in the VO tools, and those you may want to have a look at them because they are useful also in the step of data analysis, in particular TopCat, which is oriented toward tabular data. At some point in your career, and probably earlier than you think, you will have to publish data. So this is the main purpose of Vespa. This is to propose a solution, an easy solution to distribute results and providing visibility, because these services are declared in the global registry and they will appear in the Vespa portal. This is a relatively light system. This is easy to do, and Vespa is providing support as long as there is a EuroPlanet program, at least. But the infrastructure, the whole infrastructure is maintained by the VO community, which means that it will last longer than the EuroPlanet program. When you will apply to open calls, in particular European calls, H2020 or the next one, or ERC, but also at national level, we are now in a framework of open science, which means that you have to publish the data produced during your program at the end of the program. And this is one of the topics that Vespa addresses. This is to provide an easy solution to actually publish the data produced during programs. What you have to do, and this is a bit of work, is to actually provide the correct metadata and something as complete as possible. So you have to think about this. There is a design phase when you publish data, and this is something you have to take seriously if you want people to actually be able to access your data. And you also have to think a little about the format, the file format that you will use. I've included a set of recommendations, but I'm pretty sure that I'm late enough so I can skip it. That will be here. I will say that in the modern world, the basic tool for scientists include at least a basic knowledge of web services, how to query a data system on the web, a minimum knowledge of databases and SQL-like languages. This is an extension of your Python or IDL or whatever programming language. And you want to know that because this is a tool to make mass file processing much easier. And this is historically a blocking point, for instance, for space experiments. So you want to know a little about this. And you have to know how to actually use these tools in your favorite language or environment. Again, you want to have a look at these VO tools because they are very helpful beyond the simple access to databases. But conversely, you don't want to develop your own tools and your own data and link tools because many of them are already available and they are maintained externally. And if you have a specific needs, you can still contact the developers and try to negotiate with them to implement new functions. And I would say that for your own work, you want to think a bit about how to optimize the data, the design of your own data tables or structure, even for your own work, but also thinking a bit ahead and knowing that at some point you will have to publish this. So I've prepared a lot of examples of using the VO tools, the astronomy tools in the planetary science context. I'm not commenting those, but I suggest you have a look at this. This is an illustration of the power of such tools. In some cases, we're also able to handle those funny things. I remind you that 67p is coming back. Okay. I think I'll stop there.
Thank you.
And I can take questions.
Thank you very much. We are a bit late, so we don't really have time for questions, but if you can, at 12, we will have an open discussion where they can ask questions.
Okay.
Okay. Okay, thank you very much for this overview. The next talk will be about PlanMap. If you remember a few days ago, Luca Penasa talked about GMAP. So PlanMap is basically GMAP's parent. So GMAP is
it's a single parent.
Yeah, single parent. And Angelo Pierossi will talk about PlanMap. He also happens to be my PhD advisor. And I won't steal further time from him. So please, Angelo, share your screen.
Yes, I do. Thanks, Erika. Thanks, everyone. And I will try to catch up on the time. Actually, thanks, Stefan, to catching up with part of the delay. That's again what I present now. It's not necessarily what you can find on the web. It's a bit of my impression of what we did in these years. And of course, it's not only me, but it's quite a lot of people. That's a subset. There will be even more probably to be listed. And if you see upright, there is a
Angelo, your screen disappears.
Does it disappear?
Yeah.
Yeah, it's like you're not sharing anymore.
Oh, wait, sorry. Does it work now?
Yes.
Yeah.
Okay, very good. And you still see it, right?
Yeah.
Good. Okay, so hoping that it stays. PlanMap as a start and an end date. So what I can tell you now is at least the perspective from the beginning to the end, which I will try to bring you through. Sorry. It's still there, the screen, right?
Yes.
Very good. Now, you don't need me to tell you that, of course, such a collaborative project with many partners, you see many logos below, is different from an individual one, it's different from your ERC or for whatever individual grant that you apply to. And of course, there is one dimension more, which is the one of the team. On top of it, this particular project went through a selection in a call that was within the H2020 space, the Future Horizon Europe space. And it was just a little bit of this big program and also a part of the call. So of course, it's constrained the area in which you can ask for such projects to happen. And of course, there are other constraints that I will go through in a while. One of them, it's easy and obvious, which is the cost cap of such projects. This particular one was something below 1.5 million in 3 years, which depending on the way you see it, it seems like a lot of money or like little money. Now, of course, what works for me or for us doesn't necessarily work for you. So this is not really a prescription of a medicine. But what typically is done in such projects is that, of course, there should be some excellence. So the science should be selected or deemed to be good. So the proposal should be good. The consortium, so the team that is there, actually should be good, which means that you have to convince also the people that is good. And I think you heard a lot in the previous days, for example, from Nigel on these aspects. And it's not only about science, it's not only about how the team looks like and the experience, it also should look well managed. Now that's a tricky one because how is something well managed? You don't know before it is. So at the end of the day, it's track record, which is a bit unfair in a way. If you try to do it yourself the first time, you have no track record of managing projects. And that's exactly what I've been through, and then mention in a second. And then that's something that is tricky, which is the impact, which is also something that you have to predict. And sometimes it's easy to predict, but not always. And obviously you want to sell your project, you want to get your science done, you want to get it funded, so you want to sell some impact. But what it is in reality, you will only see it after some months or mostly years after the project. And then a very important point is that are the times mature? Is it really the time to ask for such a thing? It's not always obvious. And of course, I put it in bold and red, luck. You need a lot of luck. So many times when things go well, you think, well, okay, I did it right, it was good. But many times it's only luck when things go bad and when things go well. Of course, for such projects, you have to look at the checklist of what you have to do. So excellence is one, but you have really to do what the funding agency says. So if you have an excellent idea, a great consortium, but you're going off topic in the call, your project won't go through. And on top of it, times matters. So in the case of PlanMap, we were right and lucky with respect to time. You may think, how can I do something like that? Of course, joining a consortium, it's not something that you can just do from one day to the other. So networking is important, knowledge of the community is important, but I mean, we all started as underdogs. And sometimes we have an idea, find people with whom we share the idea, we try to get the idea through, and sometimes we crash on the wall. This is something that I myself tried several times, I failed a lot, but the point is that you learn a lot from that. And even if you fail, some of these things will be useful. And in fact, some of the things that failed a lot in previous years somehow were used in future or in current projects. So you cannot tell when you need it. Why do you need it? Well, of course, in the case of PlanMap, geologic mapping is something that has been around for centuries on Earth, for definitely in modern ways for decades. And it's very important for both science and exploration, for resource evaluation, for anything. Even if you want to send at some point humans, you do need an idea, for example, of how they can process local material for Israel. And geologic mapping is at the base of it. Regardless you are a geologist or not, the importance of mapping is there. So this is one of the things. It's timely because, of course, there is many missions and there is a lot to do to actually plan for the mission and to digest the data from the mission. And one example of what I was saying, that the time can be right or not, is that this thing is not that something that you think is a great idea, you do it. No, we tried it 15 years ago, 20 years ago, decades ago, and somehow it never really worked in Europe. We tried, there was some fake start, and it didn't. The difference from what you see here, an old slide of more than a decade ago, and this, it's to a large extent data. So back then, probably there was no critical mass of data set, and the ones that Stefan was mentioned were important, and also how do you access the data, and how are they available? To do maps, you need data. If you're on Earth, you go with your car or with your donkey or on foot, and you go to the mountain or on the outcrops, you collect your data. On planets, you need essentially remote sensing, or in situ if you're very lucky. And that's the difference. So you see that the amount of data that we have now, it's completely different. It's orders of magnitude more than what, for example, I started with when I was a student at your age. So on top of that, of course, there's some motivation because we wanted to add more activity in Europe with respect to geologic mapping. We wanted to have more community to get the process a bit faster. And the end of the day, we wanted to do it not just to make a project, but to actually make this activity of geologic mapping of planetary surface, if not sustainable, going towards sustainability. And it actually happened. And you heard it before 2 days ago with Luca with GMAP. We do have heritage, and the first heritage to think of in this case is USGS, because it was pushed by the Apollo program, essentially planetary geology kickstarted, and planetary geologic mapping was kickstarted together with it. But if you look at the first planetary map that you see on the right, and the ones that you can do nowadays, obviously you have much more details. And such information and detailed interpretation is not only due to the fact that you have higher resolution data, higher quality data, spectral, spatial, whatever. It's also due to the fact that you have overall more knowledge that has been sedimented through time. And this knowledge, in the case of the moon, is obviously owing a lot to the Apollo exploration. Now, when it comes to PlanMap, when we try to do these things, we could have also done them separately, because each partner was already active in mapping. So why don't you do it alone? And that's a good question, because many things could have been done alone. So why do you do this as a team? Well, you do because, of course, the sum of the efforts from each partner, when you are in a project, it's not just a linear sum. It's more than that. It's synergistic, and you can do many more things. On top of it, if you want to work together in different countries, you do need some kind of umbrella that funds this, because if I'm in Italy, I can get Italian funds, and maybe I can get Italian partners with a print project. But if I want to work with the Swiss, with the French, or with the British, I can't. And that's exactly what we did. We put together a consortium with different partners scattered through Europe, and each partner was responsible for certain work packages, so to say, but obviously all the other work together. So that's, regardless the graphics, it's the way a project with different partners that are spatially localized works. Whether this is exactly what to do at the end, it's another story. but typically it is very close to what you have to do. And when you write a proposal, you do write down more or less the blueprints of what you want to do in the project. And when the proposal is funded, more or less these blueprints are fixed. So it's like if you want to build a car, you have time to design, which is the proposal stage, and then you have to try to kind of fix it, which is between the start of the project and when it has been selected. After that, more or less, the car is in production, and then you have to drive it. And sometimes the car breaks, but if you were wise enough to select the consortium, to think about realistic outcomes and objectives, probably the car will come with you. You see here that there are different stages: the proposal, the DOA, which just means description of action, which is more or less the manual of what you are going to do. Running the project, of course, which theoretically should follow the so-called DOA. And then you have some end of the projects. After the end, you have the impact, essentially. You can have impact also during the projects, but when it comes to mapping, a lot of impact can be years later. So typically, some things are changing, but really the bulk of it doesn't change from when you finish making the proposal to the end of the project in terms of structure. In terms of outcomes, it can change quite a lot. Now, this is just to tell you an example of how it changed the length of the work packages and tasks between the DOA, so start of the project, and the end. Mostly, they are as they were. You can see that some were prolonged, which means that you have to work a bit longer to achieve the thing, and the same is for the deliverables. The deliverables are essentially the results of all your projects. You a report, a paper, a map, a tool, a code, whatever, a data set. This is the beginning, this is the end. And if you see, mostly were on time, and some of them were shifted, not because we were lazy. In fact, you see there is also the COVID icon, because some of the things, when you plan them, they're different from the real thing. So actually, you have to make some change in your plan. And this is perfectly normal. These changes are called amendments in the EU jargon. Sometimes you need amendments, sometimes not. But at the end of the day, you may change along the way, but you cannot change that much, of course. Otherwise, you will be questioned. An example of how one could work together. How can you get the maps that you will do it with your, for the non-geologist, mapping the contacts and the morphology of the planets with the composition information that you get from spectrum? Well, you can do many things. This is an attempt. You don't have to look at it in detail. You can have the PDF later and look at it. But basically, you want to try and integrate what you see on the right, which is more or less a result of a spectral mapping, with something that is a typical planetary geological geomorphic map. You can do it simply adding attributes. You know, this unit here is red, which means that there is a certain mineral species in. So I can just say that this is a basaltic olivine-rich flow. That's it, or unit. And of course, once you do it, you have to make compromises, because you have not necessarily always full data coverage. You have some uncertainty. So there is, along the way, compromises and choices that are made. And at the end of the day, you have a map. And remember, a map is a model. Every geologic map is a model, regardless, is a numeric model, is just a conceptual model, but there is interpretation in it. So it's not only data, there is interpretation. But as long as you actually keep all the data that you use and the process documented, of course, you can limit the possible mistakes. And even if there are mistakes, you can catch them, or someone can catch them later on. That's why it's important, of course, to make this mapping effort reproducible. Again, models can be geometric. So simply, if a geologic map is the top of a cake, what typically we do in geology is try to figure out what's inside the cake. And on Earth, it's relatively easy. On the planets, it's somewhat more tricky. And we try to figure out what's in the cake, cutting through, again, with different ways that we have no time to discuss here, and doing it more or less quantitatively, or more or less with a numerical approach or an analytical approach, can lead to improved models. Now, to close in, PlanMap has the luck to be observed from cradle to grave. And if apart from the 2009 bullet, the idea was more or less around since almost a year, 6 months before the submission. So basically, Matteo was sending me an email, Matteo Massione, that is the leading institution at the University of Padua, and saying, you know, I have this idea, I have this consortium in mind. Then we iterated a bit, and finally we said, okay, let's make a proposal. This was done, was prepared, I think, around Christmas and the beginning of New Year of 17. It was submitted 2 months after, in March. It took 2 or 3 months to get it evaluated, and we had some months then to decide where to start. And it started in February, and it ended up in January 2021. So basically, once this is done, of course, you have something that is left. You have data left, and you have tools left. Of course, you have papers, you have knowledge, can have code, you can have a lot of things, but essentially you have data and tools. And these data and tools can be reused or can be abandoned. Now, probably you can have a look yourself to have more details here. You will have access to the PDF. All the materials, in fact, of PlanMap are public. The data, the maps, the documentation on how these maps were done, and also some extra bits. So basically, this is what is left from such a project. And many of the projects that you can see around, there's still a website, and essentially data and papers are the heritage of this. And one can say, which is the impact of this? After a few years, saying, was it worth the money? Which is a difficult question to answer. For PlanMap, we already had in mind that we didn't want to finish it like that. We wanted to make something a bit more structured for the community, and that's why the infrastructure of planetary science, Europlanet, came, that was actually being restarted with a new bid 2 years ago, was really coming at the right time, and PlanMap was halfway or so. So basically, we had the occasion, which was a very lucky strike, to use the outcome of PlanMap for GMAP and to build on it. So what comes in the future is still to be seen, so I cannot tell you what's going to happen. But of course, we will try to make the effort and make some use of what PlanMap did. And on top of it, this is valid for our proposal, for your current and future proposals. You don't know what's going to happen in the future. And sometimes you get rejection for job application for proposals, many of them. It doesn't matter. I mean, there will be all the green paths ahead, and a lot of things that you failed with or we failed with can be really useful in the time that you really don't expect. Thanks, and we can discuss the rest later.
Thank you very much. I already saw that there are questions, so we will discuss it in the open discussion at 12. Thank you very much again, and we move to the next speaker, if he's here. Harry?
Yeah, hi.
Hi.
Thank you.
Good morning.
Good morning. Thanks for having me.
Thank you for being here. So today, Harry Becker will talk about TRR 170. I'm very happy about this because I personally enjoyed a couple of summer and winter schools that they organized, and it was really a great environment, and I learned a lot. So I really wish all of you could have that benefit one day. And now I will leave you the space. Feel free to share your screen so you don't have to say next, please.
Okay, let me just try to find this, and where do I have to do this? Yeah, okay. Here we go. All right. Okay, can you see this?
Yes, that's perfect. Thank you.
All right, thank you very much. Yes, this is, I would like to introduce this program, which is actually been around for a while now, but some of you may not have heard about this. And so I will talk about basically what is the scientific background of what we're doing, and then towards the end, explain some other aspects of the program that might be interesting for some of you, and which is more about, you know, what we have to offer. So this TRR 170, this is sort of the DFG number. DFG is the German Science Foundation for this program, and is a collaborative research center that is hosted by Münster and Berlin. And the participating institutions are shown at the bottom. This is the Institute for Planetary Research of the DLR, the German Space Agency in Berlin, then the Technical University in Berlin, Freie Universität Berlin, which is where I'm from, then the University of Münster, and the Museum of Natural History in Berlin. And I'm currently the deputy spokesperson for this program. The spokesperson is Thorsten Klein in Münster. So this, in the first funding phase, I was the spokesperson, and so we have sort of switched this. Now, what is late accretion? You probably know what that refers to, but I would like to show this here in this diagram. It's basically the final part of accretion of terrestrial planets. So after the main growth phase, in case of the Earth, like the presumed major collision with an embryo that led to the formation of the moon. But that was not the end. And after that, there was additional accretion, and there is reason to believe that this had also a substantial impact on the later evolution of the terrestrial planets. So what main objective is try to understand the causes of events, starting basically with the last giant impacts, the last stages of the main growth phase of the planets, and then into the later evolution. And if you're more Earth-centric, then you could look at this time scale basically from the formation of the moon into the the time when the major lunar basins formed towards the end of that time, so maybe around 3.8 billion. So that's the time scale we are looking at. And the program, as I said, this is funded by the German Research Foundation, is sort of divided into three research areas. This is just a matter of convenience and the way this is organized. And so we have projects that concern the timing of processes, then the chemistry of the materials that were involved, and then of course also the geodynamic processes and implications that were relevant for this time scale and the processes involved. And I would like to talk a little bit about these different research areas. So when we talk about timing, we have projects that study, of course, the evolution of the accretion of smaller bodies on the surface of the moon. And so you probably notice that there is different ideas about how this evolved in terms of the bombardment history. Some people think there was a late cataclysmic spike at around 3.9 billion years that produced most of the basins on the lunar surface, but other people think it was more like an exponential decay. And so we have isotopic dating projects and crater counting projects that study this, try to find new and improved evidence that constrain these models. And then, of course, we have people who do impact simulations and lots of modeling studies in which we try to better understand how planetary surfaces are affected by impact processes, in particular by large impact processes. We have people who are interested to more closely narrow down the age of the earliest lunar crust. And with that, and including some of the modeling aspects, try to understand what the likely age of the moon is, which is still not really that well known. And then finally, we also went into, this is now in the second funding phase, more towards trying to compare the moon, the cratering history of the moon with that of Mercury, as Mercury is another larger object that has a substantial record of these processes. So this is what we do in terms of timing in the second funding phase. And what we strive is basically to come up with a quantitative bombardment model for the moon. And this is something well underway, and there is already publications where we combine various aspects that include not only models of the bombardment history, but also chemical models that use chemical tracers for hydrophile elements, for instance, and try to come up with constraints for that. So that would be timing, and then the B part of this project is, or of this consortium, is trying to understand, of course, the chemistry of the accreting material. And this is something that is really has benefited from a lot of new evidence that sort of is still developing and came up in the last decade or so. You may have heard that the materials that arrive now on the Earth or have arrived recently, the meteorites, they are now believed to be originally derived from different positions in the early solar system. So people distinguish carbonaceous meteorites from non-carbonaceous meteorites. You may have seen these kind of pictures. And their changes with time, the changes of their position, of their origin with time, is probably linked to the orbital dynamics of the giant planets. And there is lots of work where there is a lot of fertility between planetary science and also astrophysics and celestial mechanics in recent years. And these studies indicate like the carbonaceous meteorites were implanted into the asteroid probably relatively early. And then there was later, as a result of potential dynamical processes, further implantation or transport of such materials into the terrestrial planets during the later growth history. And this is also something we are studying using sophisticated approaches. This is mostly geochemistry or cosmochemistry that use isotopes, nucleosynthetic isotope variations, but also stable isotopes, and petrologic work on foreign inclusions in meteoritic breccias. So the questions that are being addressed here is, of course, what is the origin and composition of the accreting material in terms of volatile content, for instance, also. And were there changes in the composition with time and location? So we have currently projects that compare Mars and asteroids with the Earth's moon system. And also the question is of relevance in how far the late accreted material, for instance, to the moon or to the Earth, was compositionally similar or different from material that was accreted during the main stages of terrestrial planet accretion. So this is one important aspect of chemistry, but there is a second part that is that since we also have, as you will in a few minutes see, that there is lots of geodynamical processes that need to be studied. We need to understand the chemical process during the differentiation processes, and this involves study of the role of volatilization processes, for instance, from magma oceans, core formation, and also silicate differentiation. And we do this now in particular to understand the moon, but also some of the asteroids and in particular the Earth and Mars. If you want to study these planetary chemical processes that are mentioned here, you also have to bear in mind that the precursor materials also were affected by nebula processes, in particular when it comes to the volatile contents. And we have projects that combine these different types of processes and try to obtain more information on these things. So yeah, and this is being done by using trace elements and isotopes. I'm not going to discuss this here in detail, just to show you this is strongly chemistry-based research. So the final research area, of course, puts all this together to some extent and is trying to understand how far then these late accretion phase was affecting the evolution of the interiors and atmospheres of the terrestrial planets. And you see here the whole scale of processes that we study here. So this involves the role of large-scale impacts and how they affect the mixing then that occurs later, and the dynamics, core formation processes, and magma ocean evolution, and what the time scale of these processes is. And so you can see these links to the other research areas. And of course, there's also the chemistry involved that I just was mentioning in the previous slide. So element partitioning, what is the effect on heat production? And that, of course, also has an influence on the early crust formation and the early mantle dynamics. So we have projects to study that. And then finally, of course, also because the atmosphere system is coupled to the interior, trying to understand, for instance, the redox evolution of the atmosphere in the interior. So this is, you can see this is quite a scope of different projects. And I have, for this geodynamic implications part, I just have an example here to show what we do. So we have people who can do impact simulations. And so one of the key questions is how the fragmentation of impactors work. And people who do convection models of planets then study how this fragmentation process or the fragment size will affect the subsequent mixing of within the mantle or within the planet. And then this is then combined with chemistry, where people study particular isotopes that can be used to trace relic impactor material in Earth's mantle. So that is the question, is this feasible or is this not? And the models basically can address this question. So yeah, so this is about the science, and I have a few more words and a couple more slides to show some other aspects of our program. This is of course not only about research, but also about education. And so this is some statistics here. This for the current funding phase. So we have 19 PhD students, 10 postdocs, and 18 PIs. And of course, it's an international group. And currently, the coordination office is at the University in Münster. And a part of this is we talk about education, that we have, of course, for our graduate students, a graduate program. And so they get these, what is common these days, soft skill courses, but also workshops that are related to scientific aspects. We have a visiting scientist and a fellowship program. So this allows PhD students to come for temporary visits and to work with some of the PIs if they wish, or to work with postdocs. This fellowship program also, applies to postdocs and to senior scientists. So unfortunately, because of the pandemic, this hasn't been used as much as it was possible in the first funding phase. But I can tell from the first funding phase, we had a lot of people coming in to contribute or to participate in some of the projects we are having. We are in the first funding phase, we also have organized summer schools, and we are about to do this again. Again, the problem with the pandemic was that this was not possible so far. We think it is really important to do this in presence and not in a sort of like a WebEx or a Zoom kind of format. And we have funds that permits participation of external PhD students or also master students possibly in the summer schools. I just want to announce this here that we have that. And for the near future, so we have we have 3 of these schools planned. The first one will take place this September. This will be, because of the current boundary conditions, will be only the Transregio students. But the plan is for the next summer school, which would be planetary geodynamics in May 2022, to have also external participants. Then there's a third one that will be probably on the origin of the Earth-Moon system in perhaps late next year or early 2023. This is not decided yet. So to finish this up here, we will advertise this internationally in various kinds of by various kinds of organizations, AGU, EGU. You will find this if you check their websites when you look for workshops. But it all depends to some extent on the boundary conditions that the pandemic leaves. If this is fading away, waning, then we can go ahead with this. But we will try to make everybody aware if we will have these schools and if external people can participate. We have the next funding period, so this program can run up to 12 years. And so the next funding period would be 2024 to 2027. And of course, we are going to apply to continue this. And then there will be new PhD and postdoc positions. And they, of course, then will also be advertised. And if you have sort of questions about the program, you can, of course, contact Sabine Hunze at the University of Münster. You can also contact me if you want. But Sabine is the person to go to. And if you are interested to participate or have some ideas, you can also contact individual PIs, of course. So that's about it, what I wanted to talk about. And that's, yeah, I'm basically done. Thank you very much.
Thank you.
Thank you.
I see that there are questions. Would you be able, Harry, to join us for the open discussion at 12?
I can do this.
Okay, that's great. Thank you very much, because we are a bit late and
okay.
we are always still in time from the coffee break. So they really want to get a coffee now. And we'll meet here at 11:30 for the last talk of the session, and then we will have the open discussion. I will keep these questions that you made in the chat, and I'll see you in a while. Thank you very much, Harry, for these incredible opportunities that you showed us. Yeah, I think there are many interested people in this moment. Thank you, and I'll see you in very short time. Thank you, Lucy. So we already had questions in the chat. I don't know if they were answered. Someone was asking Angelo if the Plan Map Winter School will happen again. Okay.
It was me more or less, because there was a comment about that. Angelo gave an answer, but maybe if you want to complete the Angelo, you can.
No, he replied, I think he will be back at 12.
Okay.
Yeah, because that was the scheduled time for open discussion.
Okay, so in any case, he said that the winter school will be done again, if I remember well. And that all the videos are available on the web, so he gave a website where it is possible to see the video.
I'm reading if there are more questions in the chat. Oh, Andrea asked, yeah, I think it was for Harry. I love this field of research. In my master's thesis, I'm studying chondrites. Do you also offer opportunities for students with master's degree or only postdoc?
No. I mean, if you have a master's degree and you want to get, interested to have a fellowship or something, you can apply. That's possible. Do you refer to fellowship possibilities, or you refer to the participation in the summer schools? Probably both. So both is possible.
Andrea, are you with us? Yeah.
Well, if she's, okay, all right. Well, actually, I'm looking for someone who can do diffusion modeling or is interested in that.
Okay, people, be aware.
In lunar samples, although not in meteorites, in Apollo samples.
That's nice. Okay, he said thanks, so I think you answered his question.
Okay.
Thank you. So if you want to study lunar samples, Harry is the right person. Let's see other questions. Yeah, the PowerPoint presentations will be available in the cases where the speakers will agree to share. The recordings will totally be available to everyone. Yeah. Okay, other questions for our speakers? I have a question actually for Harry. There is also one from Jonathan. Harry, are the TRR 170 opportunities only in Germany? Yeah, I think yes.
Yes. Well, you know, it's a German program, and we have Berlin and Münster.
I was in Münster. I saw the laboratory. It's really a great place. The laboratories are awesome, and the city is so nice. So if you're interested in working with them, I would really consider Münster.
Well, Berlin is also good. Come on.
Yeah, it is.
We get a new multi-collector ICP-MS this year.
That was just my my preference would go for Münster, but I'm sure.
Yeah, no, I'm fairly firmly lodged in the Netherlands at the moment, so I'm interested in the projects, but trying to figure out things I can do here.
Mm-hmm. Well, as I said, what we have here is the opportunity to come in for a couple of months, and you know, if that would mesh with a project that you're doing as a PhD project, this is something that probably can be arranged, for instance.
Okay. Yeah, I'm looking for postdocs at the moment.
Okay.
Yeah, but thank you.
Yeah, okay. I opened the discussion with the differences between Berlin and Münster. I was just saying that I love Münster. I have nothing against Berlin. It's wonderful as well. I agree. Other questions? Colin is not here. I'm afraid he forgot or something came up. Okay, well, if you don't have further questions, we should probably leave the speakers, as I guess they have a busy day ahead. Yeah, no questions apparently. Okay, then. Thank you very much, Harry, Stefan, Angelo, and Nicola, who's not here anymore. Thank you very much for your time. And if you have questions, I think you can contact them. They're very kind people, so I'm sure also in this case they will reply to your questions. And don't forget the opportunity that Harry just said about working with him. And yeah, thank you very much. I can't see Colin, so I guess we will wait other 5 minutes and yeah. And then we will go for lunch earlier than predicted.
Okay, I'll have to step out here. Thank you very much for having me. Bye.
Bye. I'm so sorry. I don't think he is actually joining us. He was supposed to present Astronet, which is a European project for, as you can imagine, astrophysicists. Yeah, I'm deeply sorry this happened. Okay, well, in the meanwhile, I'll say just a couple of words about this afternoon's activities. So we will be split in different rooms for each working group, and you can choose one working group or more. So you can just pop in here and then there and give your feedbacks, your ideas. Nothing is mandatory, so it's not like you sign a contract. Even just hearing your ideas, it's a great thing for us. So it's a very free session of brainstorming, and you can choose the working group that, I don't know, created more curiosity in you when you heard of it. And if you have other questions, you can ask on Slack if you have some doubts on which working group would be the best for you. And yeah, I think that's it. Colin's not here.
Erika, how do we send you the presentations?
Yeah, I was going to reply to your email, Stefan. You can also send it to me via email, and then I will upload all of them.
Okay.
I have to ask Europlanet if they have a cloud. It's okay, Bernadette, if you can only join the first session. It's okay. We understand life is busy and unpredictable.
Thank you.
And actually, the first session is the most important one, so that's perfectly fine.
Yeah.
Because you plan to organize the karaoke just after? That's fine, no?
That I can leave on time. Yes, yes.
Yeah, you do owe me a karaoke. I won't forget. Okay, well, yeah, last check if Colin's here. No, he's not. Okay,
if you need a filler, I just received a mail from EPSC saying that the Vespa presentation is accepted. We have a special session for accessing data in general at EPSC, which is one of the MI session, I think. It should be called something about that tools, data analytics and geomapping for solar and planetary sciences, MIT M4. So that will be about accessing data in planetary science in general.
okay, thank you. So if you're interested, you should definitely join the discussion at EPSC.
And I think we will try to answer one of the comments from Nicola. I think we will try to organize again, but virtually, a small workshop, training session for about virtual observatory tools at EPSC. We used to do that from the onset of the previous program, which was in 2015, I think. We did not last year for obvious reasons, but we may try to have a virtual session this year. Yes.
Yeah, sorry, I lost that comment in the chat, and thank you for pointing that out. Thank you very much. Okay, then I think I will leave you go for lunch if there are no questions. Oh, Colin's here. Hello, Colin.
Hi there. Sorry, have I got my time completely screwed up?
Hi, I thought you were not coming. It's a relief. Thank you for joining.
Yeah, sorry, I had it down as UK time.
It's okay. Later is better than never. So yeah, Colin Vincent is today presenting Astronet, and I will leave him share the screen, and I won't steal his precious time.
Sorry, can you all see that?
Yes.
I'm very sorry about the timing. It's just been a mad week.
Okay, thank you for joining.
I'll keep it as very brief as I can. So yes, so I'm the chair of the Astronet board, and I'll explain what that is as I go into this. So Astronet is a consortium of European funding agencies and representative bodies. And the idea is that we work together to look at common needs for astronomy and astrophysics across Europe. Previously, we were funded by the European Union for a number of years. And more recently, we've been funded by the particular agencies and infrastructures that are involved in Astronet. And our intent is to cover all of astronomy, regardless of whether it's ground or space, facility or technique. So we're much broader than, have much broader interests than, say, the European Space Agency or the European Southern Observatory, or indeed the various European networks like Europlanet or excuse me, SolarNet, etc. Current members, we've got a range of countries across Europe. We have observers from the European Astronomical Society, SK, European Space Agency, etc., and connections to the various European networks. So what are we doing? Well, the main thing that we're doing at the moment is putting together a new European science vision and roadmap. And the reason why we're doing this is because we believe that the community needs a strong and united vision that will convince funding agencies and other bodies that our science is important, and we can demonstrate what we can achieve, and that the science and research that we do and technology that we support is relevant for today's economy across Europe. So Astronet's the only bodies that's done this for the whole of Europe in the past. And I think the success of the ones that we have, the reports that we produced previously, was that they were highly regarded by the European Union, which looked at the recommendations that we had. They've become a scientific reference point for astronomical research in Europe. They've been influential in securing money for new projects, particularly things like the European Extremely Large Telescope and the SKA, in forming consortia for particular issues. And I mentioned WEAVE there, which is an instrument for the Isaac Newton Group telescopes in La Palma, which has a very broad European consortium supporting it. And we feed into national strategies. So we're not replacing what you might have as a national strategy for France or for Germany or wherever. This is part of a broader European vision to show that the community can get together behind the key things that it wants in terms of facilities, training, technology, etc. The original reports were produced in the early 2000s and then revised in about 2014-15. But even since then, and the science has moved on, lots of things have happened in the last 5 years, and it's time to do a new one. We also know that the US Decadal Survey is underway, and the European Space Agency's Voyage 2050 is underway. And so it's important that we have a view that covers the broader science and feeds into those very influential strategies from large organizations. And we need to include new areas that have come up. The original report didn't mention anything about sustainability or about the environmental impacts or effects or indeed need to be environmentally aware. It didn't mention really the current status of technology, of skills, and of the need for computing, AI, robotics, etc. So there's a lot to put in. I just include this picture here because this is a typical background to producing this kind of project. This is a very old graphic to do with software projects. You can see if you follow the stages through, essentially the customer wants a simple swing. We've talked to lots of people about how we can do this, and we end up with something that should be something near to the original customer's need. And if you look at the way that these international strategies are put together, then quite often you have a lot of white papers, a lot of town meetings, hundreds of people involved. The thing takes several years to put together. Where actually what the funding agencies need is, what are the priorities? What are you going to do for us? And how do we achieve it? So we're trying to avoid some of those pitfalls in the process that we've adopted. We have a number of panels which are based on science questions, and you can see the science questions here. These are very much derived from the original ones with some tweaking after talking to some of the community. And the panels, there's about 50 people involved across Europe, across science questions, gender and positions in their career. And just the chairs of those panels are listed here. I won't go into the details here, but if you want to know them, please come back to me. So there's obviously a lot of interaction between these panels and a lot of crossover in some of these areas. Things like exoplanets you can't define in one of these questions, it covers more than one, or some of the high energy physics covers more than one. And we have two cross-cutting chapters, one on computing, where computing is really broad, everything from modeling to high performance, high throughput computing to big data sets. It's meant to be covered there. And also looking at the skills we need, training people across Europe for the future, and the sustainability, which covers those environmental aspects and others. What the panels are doing, well, over the last few months, they have been putting together drafts of their chapters. And these include roughly a state of the art, and then looking at where we're going with the science and what facilities and what capabilities are needed in order to deliver that over the next 10 to 20 years. The current status is we had a community consultation in the first quarter of this year, and we had about 200 responses from across the community. That was the first stage in a consultation process. It's actually very difficult to reach the broad astronomy community across Europe. There's no single way of doing that. We put something out through the European Astronomical Society, through the various mailing lists that our members had for their national communities. And we talked, or at least made the chairs of the various panels like SolarNet, Europlanet, etc., aware of the process. We got a lot of responses. It highlighted gaps, which we knew there would be. And we also were unable at that time to have the two cross-cutting chapters, the one on computing and skills and sustainability. They weren't available. So we have more work to do. The next status step is that we have a webinar hosted by the European Astronomical Society tomorrow morning. We'll have the chairs of all the panels there as a webinar. They will be presenting their chapters and seeking input from the community. And we have a Slack channel associated with this, will be open for 10 days after the meeting to promote wider discussion. We've got about 350 people signed up so far, but we're expecting about 400. So you're most welcome to join this. It's open to anyone, but you have to register through the European Astronomical Society to get access, and the same with the Slack channel. Just to show the agenda for tomorrow, as you see, there's the various chairs there. It's quite a full day, but we hope that it will promote more discussion amongst the community and reach a wider audience than perhaps we did with the original consultation. After that, there'll be some editing of the comments and things we've got in from the community. We will release those two draft reports we haven't had yet, the one on computing and the one on skills and sustainability, and then a process of editing and putting the thing together with a view to publish by the end of this year. Pandemic willing, I should say. And just this last slide, really, this is another one which some people might have seen. I think at the moment we're somewhere between the mess around and the panic stage here. We haven't got as far as all the work while crying stage in the project. I think it's a bit disingenuous to say messing around. There's an awful lot being work done by the panels at the moment, but we haven't coalesced into the final versions yet, and there's a lot more work to do. So that's about as quick as I can scope through this as possible. The main thing I want to put over is that your inputs are very welcome. There's an opportunity through the webinar. Go to the Astronet web pages as well, because you can see the drafts there and comment on them, It's still open for particular questions if you want to raise them. And we really want this to be as broadly based as possible. And I'll end there.
Thank you.
That was quick.
No, it was perfect. Thank you very much.
Thank you for the overview. If you're interested, please join their Slack channel and their discussion tomorrow. It was very kind of you inviting us. If you have questions, we will take questions now since the open discussion with the previous speakers already happened. Jules said he loved sketches. So, any question? This was actually a missing field so far because we talked about planetary mapping and services. So we didn't talk about astronomical opportunities so far. So if you have questions, this is the right moment to do so.
I can make the presentation available if anyone wants to look.
Yes,
take the
please.
sketches.
Yes.
Yeah, thank you.
They ask for presentations indeed. So the recordings will be available and the presentations will be available. It's up to the speakers to share. So thank you very much for sharing.
I'll send you the latest version, Erica.
Yeah, thank you.
Good, that's easy. No questions.
Yeah, no questions. So we won't steal further time from you. Yeah, no questions. Okay, thank you very much for joining us.
Thank you.
I'm sure some of us will join your Slack channel. And yeah, thank you. I wish
Thank you for having me.
a nice lunch and I will see you in the afternoon. Thank you. Bye.
Thank you.